Question B says, under what conditions will it not be possible to make the system stable? So the obvious ones, okay, it's obvious for different people, but if this angle theta increases to 90 degrees and you try and put a bottle in, it's going to fall over. It's just going to go straight down. Okay, so you can't have theta equal to 90 degrees. Equally, I guess you can't have theta at 0 degrees, because then it's not going to be a wine stand and your wine butler's lying down on the job. So if you're considering this equation here, if we just quickly sketch out our cosine graph. Okay, so we're only concerned with the first section here, which is up to 90 degrees, and it goes between 1 and 0. So this part of the equation has to be between 1 and 0. It's probably got to be closer towards the center than anything else, but if it gets to, let's see, either too close to 1 or 0, if you change MC for it to get too small or to get too big, whether by changing the length of the bottle, C, so the length of the bottle will affect C, or affecting the mass of the bottle, M, or I guess the amount of wine in it. If you affect that too much, so that you go outside of that range, you're going to, practically speaking, make too much torque in the one direction or the other. Another way of looking at it, just purely mathematically, was that you had that equation before, B over A equals capital M over small m, and if this ratio, so like if you look at this as ratios of B to A, has to be the same ratio as capital M to M. If those ratios don't change, then you're fine. Then the sum of the torques, remember we did that sum of the torques equation equaling 0 to derive this condition of B over A equals M over M. If the sums of the torques is no longer 0, then these ratios won't be equivalent, so B over A won't be the same as M over M, and that'll also result in an unstable position.